This is lesson 6.3, completing the square. So our goal in this lesson is to learn how to write a parabola equation in its vertex form. We've actually already done this, but now we're going to use a different technique called completing the square. So before, when we were doing the vertex form, we had to find the zeros, find the axis of symmetry, find the a value in certain points, but now we can actually apply a technique to allow us to go directly from standard form to the vertex form that you see over here. And so that'll make it a lot easier for us and more direct, and so we'll see how to do that in these steps that follow. So we're going to try to convert this standard form here into the vertex form. So the first thing you want to do is you want to place the brackets around your first two terms, which are your x squared, your ax squared, and your bx terms. So we're going to have y is equal to brackets around here, 2x squared plus 12x minus 3. Then we're going to remove the common constant factor from both the x squared term and the x term only. So there's a common factor in these terms here, and it's the constant factor. It's not the x, but the constant factor. So common constant factor meaning not the variable. So it looks something like this. Y is equal to, it looks like we can remove 2 as a common factor from here. So 2. And then when you divide 2x squared by 2, you get x squared. And when you divide 12x by 2, you get plus 6x minus 3. And this is the part where completing the square comes into play. So find the constant that must be added and subtracted to create a perfect square in here. To find the constant, take the coefficient of the x term, so the 6 over here. Take half the coefficient and then square it. Rewrite the expression by adding and subtracting this number inside the bracket. So let me show you how to do that. So first we're going to find the term that's required to create a perfect square. So what we're going to do is we're going to take our b value, 6 over 2, divided by 2, and then square it. So that's going to be 6 over 2 is 3 squared, which is 9. So now what we're going to do is we're going to rewrite this as y is equal to 2x squared plus 6x. We're then going to add plus 9 and minus 9. So it's really like we're not really adding anything, but you'll see what we're doing in a minute. So if you do plus 9 minus 9, we didn't really modify anything because these are equal to 0. Minus 3. So I did all the steps here. I found the term that was required to make this a perfect square, right? You have the square root here, square root there, so that would make it a perfect square, but I couldn't just add 9 because that would change my overall equation, so I had to do 9 minus 9. So we're not quite done yet. What we need to do now is step 4, move the subtracted value outside the brackets by multiplying it by the constant factor. The constant factor was the one that's in the front here, which is, as you guessed it by now, your a value. So we're going to take the subtracted part here and multiply it by a and move it out. So we're going to get y is equal to 2 times x squared plus 6x plus 9. Close the bracket. Minus 9 times 2 is minus 18. And then don't forget the minus 3 there. And so now what we do is we factor the perfect square here. And then simplify and collect like terms on the outside there. So we're going to get y is equal to, remember when it's a perfect square, you simply put x, and then we can just take the square root of this number, so plus 3 squared minus 21. Oh, and the square root of this number here, which is, well, just 1x. So x plus 3 squared minus 21, because minus 18 minus 3 is minus 21. And so what we're able to do now is we can find the vertex directly. using our HK, which is -3, -21. Since the parabola opens from the top, we know this is a minimum value. A minimum value over here. It's -3, -21. Because the parabola opens from the top, it only goes up from that vertex point. So those are the main steps for completing the square. Again, it's a more direct method to finding the vertex form from the standard form. So as I mentioned, you don't need to find the zeros or have two symmetrical points. You can just complete the square, and that allows you to find your vertex without even graphing. So we're going to do a few more examples of completing the square with the following scenarios here. You want to make sure you practice it, because at first glance it does seem simple, but it can be difficult to remember all the steps if you don't practice it. Again, remember that now we're able to see if we have minimum values directly. If you know your A is positive, as I mentioned before, A is positive, this means the parabola opens from the top, which means our vertex is here, so that means that must be the lowest point, so it's a minimum value, as opposed to a maximum value. So let's try example 1 over here, same idea. We'll follow the same steps as before. So we're going to have y is equal to, put brackets around the first terms, the x squared term and the x term, plus 15. Take out a common factor if there's any. It doesn't look like there is, so our a is just simply 1 here. So we need to find the value that will make this a perfect square. So remember that we want to do that by taking our b value, dividing it by 2, and then squaring it. So in other words, we're going to do 8 over 2 squared, which is equal to 4 squared, which is equal to 16. So this is the term that we're adding and subtracting within the bracket there. So y is equal to x squared plus 8x plus 16 minus 16. And we get, and plus 15 over here. Now we have to take this out of the bracket and multiply it by the a, which in this case is just 1. So y is going to be equal to x squared plus 8x plus 16 minus 16 plus 15. And now we can go ahead and factor by factoring our perfect square here. So square root of 1x squared is just x. Square root of 16 is plus 4. And then minus 16 plus 15 is minus 1. And so what we found is our vertex. So rewrite this in vertex form. So our vertex we know is -4, -1. Is this a minimum or a maximum? Well, let's take a look. Our a value is 1, positive 1, which means our parabola opens from the top, which means our vertex is over here at the bottom, which means that this is a minimum value. It's the lowest value of your parabola, so it's a minimum value. A is positive over here. Let's try our next example here. So, same idea. We're going to put brackets around the first two terms. So we have y is equal to -0.5 x squared plus 6x plus 5. We're going to take out the common constant factor. So I typically take out the negative with it if it's at the front here. So -0.5 x squared. And then if you do 6 divided by -0.5, you get -12x plus 5. We now need to find that number that will make this a perfect square. So -12 over 2 squared is equal to -6 squared, which is 36. And so now we're going to have y is equal to negative 0.5 x squared minus 12x plus 36 minus 36 plus 5. We're going to take out the subtracted term and multiply it by the a value, which is negative 0.5. So we're going to get y is equal to negative 0.5 x squared minus 12x plus 36. The negative 0.5 times negative 36 is 18, so positive 18 plus 5. So y is equal to, we can factor this here, negative 0.5. Square root of the 1x squared is x, and the square root of 36 is 6. And don't forget, because the sign here is negative, we're going to have to make this a negative sign in here. Don't forget to put the squared over here, just like I forgot over here. That would have been a mark off, so squared there. And then 18 plus 5 is 23, so plus 23. And so our vertex is going to be 6, 23. Is it a minimum or is it a maximum value? Well, the a is negative, so that means it opens from the bottom. So a is negative, so it opens from the bottom, which means a vertex is over here. So this 623 is actually the maximum value of our parabola because everything goes down after that. So 623 is a maximum value instead of a minimum value. So now we're going to try to do a graphing example with this. Rewrite the following in vertex form by completing the square, and then graph the relation. And when we do our graphing, we're going to also graph the y is equal to x squared, the parent graph, the parent function, just to see how it compares. So we'll start off by completing the square. Again, I don't need to do my zeros this time because, well, I could if I wanted to, but we're going to take a look if we have enough information to graph it without zeros. We can actually graph by a few different methods, and we'll take a look at what those are in a minute. So let's do our completing the square first. So y is equal to, let's open the brackets there, x squared plus 6x plus 2. Common factor is 1, so our a is going to be 1. Y is equal to, so we can find the value that will make this a perfect square. So x squared plus 6x. Take your b value over here, 6 divided by 2, and then square it. So that's going to be 3 squared, which is 9. So plus 9 minus 9 plus 2. Take this, subtract the value out, and multiply it by the a, which is 1. So y is equal to x squared plus 6x plus 9 minus 9 plus 2. So y is equal to, let's do the perfect square here. So we have square root of 1x squared is x. That should be plus 9 there. Square root of 9 is 3. Our positive sign here means that this is positive over here. Don't forget to square there. And then minus 9 plus 2 is minus 7. So we now have our vertex. Our vertex is negative 3, negative 7. Our a value is positive, so the parabola opens from the top, which means that this is a minimum value. We can try graphing. There's a few different ways you can do it. So we can graph by doing the translations, right? We can graph via translations of y is equal to x squared. We can also just plot. So this is one method, or plot vertex and y-intercept. And we'll see that in the next video in more detail.